Hi, everyone. Thank you for joining our webinar on C++ Development Productivity Challenges, Overcoming the Barriers. Before we begin, just some housekeeping. Everyone will be on mute, but we encourage you to communicate with us through the Q&A section. And we, time permitting, we'll be able to go through those questions and try to answer those. And whatever questions we don't, we'll be happy to follow up with you after the webinar. So again, thank you so much for joining. We really appreciate your time and we hope you find this valuable. So let's begin. C++ is, drumroll please, TOB's programming language of the year for 2022. I know, might be a shock for a lot of you, but it is the truth. And the reason why it won is because C++ gained most popularity. It's about plus 4.62% in 2022. And also, interestingly, C++ surpassed Java to become the number 3 of the TOB index in November 2022. So a round of applause, please. I like to see virtual hands throughout the screens. I think that's a big accomplishment. And I also think that we can put to bed claims that C++ is a dying language. I hope you would agree with me on that. That said, C++ isn't entirely perfect. Many would argue that it suffers from productivity issues more than other languages. And that's what we want to discuss today. Is that true? If so, then why? And also in today's market, it's even more important because productivity and its effects on time to market and quality is super, super critical. We hear it time and time again. And this was something we know well from the gaming industry, and we're seeing it a lot now also in automotive, in industries where there's crunch time, in industries where there is a big demand and the supply needs to catch up, and everyone hands on deck needs to prove their productivity to help achieve the company goals. So with that opening, I'd like to introduce our esteemed panelists. We have the pleasure today of having both experts in C++ and in software development productivity as a whole. So it's a great pleasure to introduce to you all. We'd like to start with Greg. Greg, if you can just introduce yourself and tell us a little bit about what you do. And another question, which language do you program when you're not programming in C++? So why don't you take us away?
Hi everyone, I'm Greg, co-founder and chief exec at undo.io. And I'm happy to be joining you today from the shed in my garden where we started the company. So I'm back here to do my webinars from the shed, because during lockdown, I managed to get a better setup here than I've been able to replicate in the office. So at undo.io, we provide time travel debugging to allow developers to see exactly what their code did, step through it back and forth. So it's a real productivity play. A lot of our customers are C++, but we support other languages as well. They do still let me write code, not as often as I would like, but sometimes I carve out some time to write some code, and still kind of my happy place. Am I allowed to say C if I'm not writing C++? I don't know if that's like, if I'm not allowed to say C, I would say Python.
Excellent. C is a different language. I mean, in the TOB index, and it has its own standards. So yeah, it is a valid answer, I guess.
There's exactly. There's a lot of people who will cringe if you say C/C++, right? And they're different.
I do.
Yeah.
All right. So Guillaume, why don't you introduce yourself?
Yeah, sure. So hi everyone. My name is Guillaume, and as you may hear, I'm French. Sorry about that. I'm a C++ developer. I work as a contractor, so mostly as a lead developer, software architect, and C++ trainer. Also, my expertise extends to project auditing with a clear focus on productivity. In a nutshell, if you allow me, my aim is to contribute to the success of projects. And the key idea here is to help them to reach their full potential, or at least a part of it. So I identify risks in general and the source of inefficiency. and I create set of recommendations to address such issue. So this involve or encompass code bases, architecture, but also management and HR strategies. And last but not least, the technical depth things. So how to mitigate it, how to prevent it, and if it's possible, how to establish a clear payback strategy. It's not always possible, of course. And yeah, I'm super glad to be here today, and I look forward for the experience of discussing.
Excellent. And what about the language you program when you're not programming with C++?
Wow,
If it...
that's a good question, actually. I'm really curious by nature to experience most of the stuff, but yeah, often I like some free time. Recently, I spent quite a lot of time creating new tools for C++, but in JavaScript. So documentation tools or online tools like that. But also I played a little bit with the latest C standard. So I programmed in C, and by the past, as a contractor, as an architect, I also work with framework-based languages like C#.NET and that kind of stuff.
Very cool. And if am I allowed to say you're also an author? Are you working on something?
Yeah, definitely. Thanks for mentioning it. It's a book about challenges related to productivity. It's basically some kind of, well, for the last past perhaps 6 or 7 years, I used to compile a lot of notes about everything I thought was surprising, if not absurd, when it comes to productivity. And in the end, I had the idea, why not put together everything at the book. It's really hard, actually, to write a book. So it's the third time I started everything from scratch, because I want it to be entertaining and not just some complaints and thumbwheel.
Good. Excellent. Great. So Amir, why don't you introduce yourself?
Gladly. So my name is Amir Kirsch. I'm dev advocate at Incredibuild. A few words about Incredibuild. So we do build acceleration for the entire CI pipeline. We focus mainly on C++, but not only. So if you're in C++ or other languages which suffer from long builds, that includes compilation, but also testing, static code analysis, etc. We'll discuss productivity later, and one of the productivity issues is long cycles. When you want to test something, but you have to wait for your recent change. So this is very important in the game of productivity. In parallel, I'm a lecturer at the Academic College of Tel Aviv Yafo in Israel, and this year visiting lecturer at Stony Brook University in the States.
Very cool. And for you, language?
Oh, so yeah, the language. For many years it was Java. For many years I was dealing with Java, which I still in Java occasionally, and in C# as well. But recently it would be in the past few years Python. So whenever I want to play with something, write something very fast, it would be with Python.
All right. So I'm curious to know.
Can I just come in? I want to revise my answer, because I think the question was, what language do you prefer writing in? And I think I want to revise my answer to assembly code. That is the most, it's completely, it's the worst thing to say in a conversation about productivity, because of course it's famously unproductive, but nothing quite so fun as squeezing that behavior into like as few instructions as you can.
Nice. Yeah, and I was going to say I'm a little intrigued why no one here mentioned I'm tinkering with Rust at the moment, but don't answer that. We're going to get to that maybe a little bit later. We'll save that for our questions. But meanwhile, my name is Yochai West, Director of Product Marketing at Incredibuild, and I will be your host for today's webinar. So now that we know who everyone is and our favorite languages and what we do on the side, I want to start with our first question for the panel. So again, we mentioned the TOB. I hope I'm saying that right. Am I saying that right, guys? TOB?
I think so. I think so, but yeah.
TOB?
TOB, that's how I say it, but I never know either.
All right, excellent. So we saw that, again, C++ definitely became popular. And the question really is for you all, why? Why is C++ at the moment so popular? And Greg, I'd like for you to start us on that.
Yeah, I think there's obviously a number of reasons, always multiple things, kind of, multiple factors feed into these things. I think the most obvious is just it's a success breeds success, right? And the more people who know it, the more people who learn it, makes it easier to hire. There's loads of it. There's millions and millions of lines of code, out there, projects written in it. So it'd be interesting. I haven't seen any data on what language is most popular for a brand new project. If you're starting a brand new greenfield project, starting with the empty file, no lines of code, how many of those get started in C++? Clearly, it's going to be a lot because there's the ecosystem around it and all that kind of stuff. But there's always a huge amount of inertia. But I think C++ is maybe, I just thought of this, but maybe it's like the British royal family. Like it survives by changing like enough with the time, but not too much, right? So that it kind of, I'm not a royalist, by the way, I should just add that. But it does, it continues to evolve and change. And I think so it stays, it stays relevant, but it doesn't change too much. So it gets the benefit of all that, that legacy, that huge investment in the skills of the programmer population that's out there and the tooling and the ecosystem that surrounds it.
Yeah, I haven't heard BRNA be referred to as our queen yet, but that definitely is
matter of
something.
Time.
Is something that can. The visual that is intriguing, definitely. Guillaume, what are your thoughts?
Yeah, I think I totally agree with Greg. Also, I'd like to mention that stability over time when it comes to the ABI and the API really matters here. I think this is one of the greatest strengths of C++. However, it's not always great because it's really hard to introduce new breaking change. But when comparing to new challenges, new competitor, new languages that are appearing today, like Rust or Carbon or CPP2, CPP-front, I think it's really important to foresee how this language will evolve over time and how stable they will remain. If I remember well, Carbon made a clear statement that they don't really care, at least for now, about their ABI stability, and I think it might be an issue in the next decade. I would see.
Yeah, I think that's an interesting one, right? Because it makes me think of the Linux kernel, which famously doesn't have any ABI stability inside. It's very stable from the kernel to the user space. But if you're writing a driver or something in the kernel, there is no ABI stability, which is completely different from Windows, which famously will allow you to run your driver from ages ago. And it's been a huge benefit for Windows. You can like load your device driver from your 25-year-old device, and like maybe it'll maybe or maybe not, but you've got a chance it will work. But it also slows down the development of Windows and allows, I think, Linux to move much faster. So yeah, there's a sort of long-term versus short-term trade-off, isn't there, with that?
Definitely.
Yeah,
Amir, what are your thoughts?
So I totally agree with the points raised. I would add that C++ gives you the strength. I mean, you get the strong tools in the language with great liberty. You can do many things with the language. I would say anything that you want on the machine, like you would do with C. And the compatibility with C is very important. We discussed C as being the other choice might be, and many people come from C. And the transition to C++ should be quite natural with the additional abilities that the language brings. And it is a multi-paradigm language. So in a way, if you want to be functional, you can be functional. You want to be object-oriented, you can be. You can mix and match with a proper mixing and proper design, but you have the liberty. And in a way, this liberty gives you productivity. It also may hurt your productivity if you do things wrongly, but if you work as you should, I mean, you use the right tools, you follow the right best practices, then I guess you would get the productivity with this language.
Interesting. So we have the popularity, but of course we also mentioned that it doesn't come without its challenges. So when we speak about productivity, do you think that C++ challenges are different from other languages? Are they bigger? Are they smaller, comparative? And part of this we'd like to discuss, I think, the challenges that you see, from the eyes of a C++ developer, both from its complexity, the language itself, versioning, multi-paradigm also as a factor, tools that are available. So, covering all those different things. Greg, why don't you start us off again about the challenges?
Yeah, I mean, clearly there are a lot of challenges, right? And I think there are challenges that are, if not unique to C++, then, extreme and probably worse in C++ than in other languages. And the biggest, I think, is just the size of it, right? It's so big as a language. It's basically it almost is a full-time job to just keep up with it, right? And I spend a bit of time hanging out at C++ conferences, which I suppose most people would find very strange. But you get like you and it's fascinating to see some of the arguments over dinner between proper C++ aficionados, members of the standards committee. And there'll be I've seen arguments about, I can't remember the details, but are you allowed to call a destructor from a raised exception if it's like a Tuesday or something? And and they'll get into arguments, and people like pull out the standard on their phones and scroll through to see like what and what isn't allowed. And that just gets bigger and bigger every time the latest version comes out. There's more of it, right? Nothing gets thrown away. We just add stuff to it. And I think what this means is you get this kind of sort of rich person and pauper kind of world where like if you're able to invest the time and you have this capability to really keep up to speed with everything that's happening, you can be super productive, right? But there's this kind of strong drop off, I think, whereas you can be actually quite productive in, say, Python, with not understanding everything about the language and all the pitfalls and all the things you shouldn't do. Whereas you get the sort of the curve of experience versus productivity in C++, I think is much more of a kind of S curve with having to get quite far through experience of really understanding all of it, and then just keeping up. And there's so many kind of pitfalls, and well, it's okay, just like don't do that, right? Don't raise an exception from above the line, as they call it. And it's like you have to know that stuff, right? And you can't use a smart pointer here, and then you should, and it grows. I think there's something going on where an awful lot, it seems to me, of the new features that get added to C++ are there to fix problems in the features that got added last time or the time before, right? And they fix problems that came from the time before. So it's never got over that, in my view. C++ has never got over this thing of trying to build a kind of a language with exceptions and other kind of modern object-oriented features, but having the performance, not being garbage collected, and having the raw performance and the kind of best of both worlds, and refusing to kind of compromise, which is admirable. But then it just ends up growing and growing and growing. So I do worry, like, where does this end?
Good question. Guillaume, what are your thoughts?
Yeah, I totally agree with Greg when he said that there is the learning curve for C++ is really steep. Recently, I experienced teaching C++ to multiple groups of junior developers that just to finish their school, and it was a really interesting experience, actually, because I learned a lot from that. First, I learned that there is a lot of misconception about C++. Most people think that C and C++ is quite the same languages. I saw that almost every day in company, even with experienced C++ developers. So it's really surprising. And in another end, I used to ask a simple question when I start my trainings: is that what do you think C++ is? And I can answer you that the answer is always really surprising. Most of the people say, for instance, that C++ is an OP language, and it's not, we mentioned before, it's a multi-paradigm. C++ is for low-level code, and yeah, once again, it's wrong, it's multi-level, you can do super high-level abstraction with C++. And then it comes to a lot of criticism and complaints about the languages. I met a lot of developers that are not happy at all programming in C++ on an everyday basis at their work, because it's sometimes too complex, and as Greg mentioned, it's almost a full-time job to keep up with the new features, and how verbose it is, so how difficult it is to understand new code bases. We have nowadays really large legacy code bases, and I think it's really interesting because we have a really high inertia in C++. No matter what, we can't migrate those code bases from a languages, which is C++, to another. It's not an easy task. Perhaps CPP front here is the answer, perhaps Carbon will, I don't know. But yeah, basically, people don't want to struggle anymore with code that is really hard to read, maintain, and perhaps sometime even write new code. And the last fact that really surprised me is that people are, or at least the people are trained, perhaps it's not relevant, but they don't really understand what are the paradigm and idiom that C++ have. They are coding in C++ like they will do in any other languages, perhaps adding some row pointers and a bit of memory allocation here and there, and that's it. And I think it's really sad, because if you are not using idiomatic ways to achieve things in C++, then you are totally missing the point, and you end up with code which is sometimes, if not always, even slower than perhaps a Python or any other language. So you should have a really good reason to do C++ and the knowledge to achieve your goal.
Yeah, I think that like one of the things that I think Python's quite good at is that for culturally being quite opinionated, right? And this notion of Pythonic, right? And whereas every C++ code base has a completely different culture and looks totally different. And you know, I think one of the things I find most challenging is I can look at a function in C or Python and figure out what it's going to do, right? If I've got decent documentation for the functions that it calls, you can kind of mostly figure it out. Often with C++ code bases, you have to kind of understand all of it in order to figure it out. And things like you can do operator overloading in Python, but nobody really does, right? Apart from in the very sort of specialist. People love the operator overloading in C++, and they confuse, I think people often confuse productivity with being able to, like, it's not how many characters you need to type to get something done. I've worked with brilliant programmers, way smarter than I am, who would write code that they could change almost completely by changing a single character in the source code. They could change anything. They could change any change you want them to make. They could make it in a moment, and it would all work. But for mere mortals like me, it was like impossible to read it. Right? It's just too complicated, just too clever. And I think there's a sort of culture of you know, I think if there was a culture more of keeping it simple, yes, I could do this with operator overloading. I could make this in one line. I could make that line kind of look beautiful as a single line of code, but does it get me anything? Like, I never understood what operator overloading actually, why bother, right? Why not and also function overloading? Like, just like add an underscore and put some other characters on the end of the function name, and then you know what's getting called.
I'd like to react on that, because I think when I'm teaching C++, one of the most complicated feature to teach and for myself to learn across each and every standard is function overloading. Definitely, it's quite common actually when I come and I'm auditing a new code base. I'm trying to figure out what such piece of code is actually doing, and I have a function call on the line, and I'm not even able to understand which of the overload candidate is then called, because basically my mind is I'm not a genius. I can't process all the rules, and even sometimes compilers are not really okay with each other, like GCC and Clang. They don't resolve the overload resolution is not the same, and it's super confusing. And we can't expect, especially junior developer, to understand that, especially if you are using some student debrief or some kind of template metaprogramming to enable or disable functional at compile time based on types or sometimes NTTPs, stuff like that. And I think definitely function overloading is the most complicated feature in C++. Perhaps you won't agree, but to me, it's at least the one which is the greatest source of confusion for simple code, because it looks simple, right?
Right, and what does it? I genuinely don't understand what the win is, right? Other than maybe a little bit less typing. And like I say, that the code, yeah, this. I'm all for elegance and beautiful code, right? I'm all for that. But well, actually, let me say that a different way. Not really, right? It's better to be pragmatic. And yeah, maybe the code's a bit more ugly and takes a few more characters, but if it's clear,
readable and maintainable.
Yeah, right. If you can make it beautiful as well, then great, do that. But first priority has to be readability of the code, right? And we spend way more time reading it and trying to understand it than we do typing it in.
So I agree and disagree with the points raised. In a way, I think that most of the points are saying that C++ is different because it is more complicated, or maybe the programmers in C++ are smarter and doing too many fancy things. And I think that what makes C++ maybe more challenging is, I would say, the problem domain. I think that in most cases, the problem domain that we program in C++ are more difficult. I mean, if we go to something that we choose C++ for, the problem domain to begin with was more complicated. Otherwise, maybe it was easier. Maybe we'll do that in Python. We don't need efficiency. We don't need performance, latency, throughput, etc. Okay, maybe we'll do that in Python. And if we try to be too fancy in Python, we can screw up things there as well, or in Java. And Java evolves as well. I mean, Java of today is not Java of 10 years ago. If somebody learned Java 10 years ago and go now to Java, he will say, oh, this is all new, different language. The same as somebody in C++. So I think in a way we rumble about things in C++. At the end, it's the same ecosystem in other languages. In a way, it's the same problems, but it might be that in C++ it is a bit bigger, a bit sharper, maybe because we have sharp edges. And the sharp edges are in a way, in many cases, the problem. Greg, you want to react?
So definitely I was going to disagree with you, but then I started agreeing on the sharp edge is definitely the problem. But I think I have a bit of an issue with the thing of the problem domains being harder, right? Because I think actually computer software is one of those things. I think it's pretty unusual actually, in that we just make programs to be as complicated as we can deal with, right? Programming is just always this job of sort of managing complexity, and it doesn't matter if it's written in Python to do something quite simple, because then we generally have less time and fewer programmers and whatever to do it, right? And just less resources to test it and everything else. So we just always, any kind of programming, we're always up against it. We're always actually, and programs just tend to take right up to the limit of what people can manage with, and then beyond, right? And then it's just this nightmare of, I mean, what is it? The Kernighan, one of the inventors of C, says in one of my favorite computer science quotes is something along the lines of, everyone knows that debugging the code is twice as hard as writing it in the first place. So if you're as clever as you can be when you write the code, how will you ever debug it, right? And it's quite a well-known quote, and I think it's which was made probably 50 years old or something, but it's so this is obviously a problem that goes back a long time, because we as humans, actually we as programmers, we always we're over optimistic, right? We always think we're smarter than we are, and we embrace, we jump on these problems. Yeah, I can do that, and it turns out that we can't. If you're not that way inclined, you're like most people who try programming and decide it's a horrible thing and run away from it and never get into it, right?
Mm.
I love how you shifted from humans to programmers. That was I caught that.
But then again, if we go to the sharp edges, and I think that in a way it goes back to you, Greg, as okay, we have the sharp edges. We have to be smarter when we debug than when we code, and we cannot, because when we code, we used the most that we can from our brain, so we need to use the right tools.
Yeah. Right.
So
I mean,
we cannot go like, oh, let's just do it accidentally. We have to be very methodical. We have to use the right tools, which brings us to the solutions. I mean, there is a productivity issue, there is a productivity challenge, but it is solvable. We can mitigate. It's maybe the word solving is not the right word. We can mitigate.
Yeah. Oh, don't get me started on the way still that most programmers debug most problems is printf. Right, or whatever version of your,
which I would not. I mean, it is better than just saying, okay, let's try to move lines.
No, but yeah, okay, I've seen that as well. That never ends well. Yeah.
All right, so we're talking challenges. Let's jump into some solutions. I think you've hinted to a couple already. Amir, why don't you start us off?
So again, I think that the first thing is to understand, I take what Greg just raised, that you shouldn't be too cute, too smart, trying to show off in a way. You should be very organized. The code should serve not only you, but those who would come after, which include you in a way. And then you would be able to maintain the code. Readability matters. Follow the best practices. We raised the question of, should you know everything in C++? And my answer would be no. You have to be able to write decent code using the recent standard that you're using, but you do not have to know everything. And when you come to something, when you read code that you do not understand, don't try to guess. Ask somebody. Go and learn that in order to maintain it correctly. But it's not a 1 day or 1 week or even 1 year challenge of I have to know everything, and it's like chasing your own tail, because it keep evolving. You have to get enough knowledge, be a good programmer, and then use the right tools. And being productive in C++ is like being productive as a programmer, and still having in mind you have the sharp edges. And I will take a few examples. Like, for example, in C++, debugging is harder, I would say. You may have dangling references, memory leaks. So first, use the right tools, best practices. And then when you have issues, use sanitizers, use static code analysis, use the proper debugging tools. C++ suffer more than maybe other languages with build time. Then use the proper tools for accelerating your build time. I mean, don't rumble about, oh, we have a problem, when the solution is out there. You should try and see what the industry is using for each domain in the language that you work with. So knowing the environment, knowing what you can use, it's not only on a specific person in the team, it's for the entire team. Being knowledgeable, I say this solves or mitigates most of the issues that we discuss.
Yeah. I like it always amazes me how I think actually we're getting, as a community, we're getting better at this over time, but still how little investment people make in both in terms of spending the time to become familiar. There's a lot of stuff out there. You don't have to invest in terms of money. There's a lot of stuff out there that's free, like Dress Sanitizer and the other sanitizers and Valgrind and various versions of static analysis and stuff. And people just don't invest the time. There's like this metaphor, like, if sometimes people are too busy bailing water to fix the holes, right? And I mean, sometimes that is actually true. You've got to bail enough water that the boat doesn't sink. But if you just keep on doing that, it's just there's a small investment of time now can save so much time in the long run. Like the payback is, you know, the ROI is you know, 100-fold, right? Maybe more sometimes. And then the other investment is in terms of just money, right? And I think we're getting better at this. I think the C++ community in particular has been one of the worst. I sometimes say, and this is from somebody who, like, you know, from my as my day job, I'm trying to sell software tools to C++ developers, right? So I'm kind of jaded, but there's this kind of attitude sometimes that it's like programming tooling is like sex. If you have to pay for it, then there's this kind of shame and stigma around it, right? And you should be able to just, like, you know, figure it all out and do it yourself. Well, no, not do it yourself. That's not, anyway. That's where that metaphor breaks down. But yeah. So, you know, we invest, and then, you know, investing in just some money. You know, these days I'm very happy that software developer salaries, you know, are you know, probably a bit of a blip right now, but over the medium term going up, you know, a lot, and programmers cost a lot. C++ programmers probably cost more than average. And, you know, companies will really balk at spending a few % of a software developer's salary on technology that might make them, you know, 10, 20 more %, you know, more productive. It's kind of strange.
Yeah, I agree. Guillaume, any tips from your side on some good solutions?
Yeah, sure. About what Greg said or Emir a few minutes ago, I think we should take into account that there is, at least that's my opinion, a clear trend to simplification in C++ nowadays. If you take a really simple example, we used to do some kind of super dark witchcraft metaprogramming stuff, and yeah, for instance, for the detection idiom, it was really hard. I think it's quite unreadable, especially for junior developers to read such code we could produce perhaps a few years ago, back to C++ 11 and so on. However, nowadays with concepts, we can achieve quite the same result. And I think even a newcomer in a team or junior developer can easily understand such code. And this makes me think of many of Kate's Gregory talk at CPPCon or other C++ conferences. She used to say that how important is it for you to prove using your code that you are a great C++ developer. And in the end, it's always damageable for a team if you are doing some code that looks quite obfuscated or really hard to read, especially for developer. And she had another talk which says that simplicity is not just for beginner. And as Amy mentioned, when we create new code, especially in C++, I think we should always take into account that we are the one most likely that will then maintain it perhaps for the next 10 years. It really depends of your job, of course. But yeah, I think it's super important to take that into account.
Yeah, absolutely. And an analogy I like is actually with programming. This isn't just C++, this is across languages, but I think it's particularly problematic in C++. Is programming is like riding a motorbikes, right? I don't ride I ride a pedal bike. I don't ride a motorbike. But the analogy was when it's usually young men who start riding motorbike, and they whiz around as fast as they can, right? And they're weaving in and out of the traffic, and they're going right at the limit of their ability, like right at the edge, and they think that makes them expert motorcyclists. Now, sort of Darwinian selection applies a little bit, and, you know, a bunch of them get kind of taken out the gene pool. But those who survive and carry on riding motorbikes as they get a bit older, you know, they start to become well within their limits, leaving lots of space, not going too fast. That's a much more skilled, you know, much more experienced, much more skilled motorcyclist, not the 20-year-old herring around. And it's exactly the same, you know, with programming. Is you know, you realize at some point in your career that you know, hopefully the consequences aren't quite as bad as riding the motorbike too fast, but, you know, it's not cool.
The consequences might be for the users.
I mean, it can depends what code you're writing. I mean, hopefully people aren't doing this in, you know, flight control software and stuff, but there's, yeah, we all know of, you know, there are stories where, you know, where people do, but yeah, there's a weird, like you wouldn't think of programmers as you wouldn't think of kind of machismo as being stereotypically a problem in programming, but even within programmers, there is this kind of weird kind of twisted machismo.
As we said, trying to show off in a way, which if it works, if it serves the matter, that's fine. If it doesn't serve the matter, I mean, readability would be hurt. It's bad for maintainability. At the end, somebody needs to approve. The process should be, there is a code review. I'm not getting in any new dream of somebody to build here a monster.
Yeah. Yeah.
We have a question from the audience that relates in a way to the complexity of C++ and things that we raised about people who come to C++ not from C. Where should we start? Where should we start with C? And I think that Kate Gregory has a very famous talk about if you are teaching C++, don't teach C.
Yeah, it's the correct name of the conference, if I remember well, is Stop Teaching C.
Yeah,
and
stop
I think the one she did the most.
Yeah, people usually take only the beginning of Stop Teaching C, and Craig Gary says, no, this is not what I'm saying. I'm saying stop teaching C if you are teaching C++. So the idea is that you can start with C++ without taking the programmer into pointers. I mean, they may know about pointers, but you do not want to practice them of writing destructors and pointers and copy constructors. You want to start with rule of zero. You want to start with smart pointers. Maybe you want to start with value semantics.
Yeah,
value semantics
that's what I do.
Is mainly talked recently in the recent years. And as you go into it, there is a reason why Dave Abrams and the others are talking about value semantics. It is efficient. It is more safe. We didn't talk about safety or security too much, and maybe we should say something that, in a way, I think that these are two different things, productivity and working on safety, which go together but need different mitigations.
Absolutely.
So you have to think about productivity, and you have the tools for that. Maybe in a way, same tools like static code analysis can serve for both, but these should be measured separately. And maybe when you talk about productivity, you will find out that C++ can be productive, and the other languages that come along might not serve better for productivity. Maybe they would serve better for safety. So
yeah, I mean, like
another question.
The elephant in the room here is Rust, right? We're coming towards the end of this panel session, and nobody's mentioned Rust apart from Yohei right at the beginning. It's surprised that nobody's mentioned Rust. So we have to surely we have to address that. And I think that's spot on, Amir. That it, like clearly C++ and even more so C have a safety problem, right? And I think that's just, the evidence is just clear. There's like something like 75% or something of CVE vulnerabilities come back to memory safety, right? And that's clearly related but different from productivity. But yeah. So there's a whole class of bugs that a lot of languages you just can't have. But those languages you'll get different kinds of bugs, and so productivity will still hurt you. But yeah, it's good. I think it's really interesting. I think one on Rust. I think Rust could be the best thing that ever happened to C++ in the same way that Clang was the best thing to happen to GCC. Right? I think it can kind of force competition is good and all that, and I think it kind of forces to say no, it's not acceptable that we're writing all this code with just every 75% of the time there's a security problem. It's the same bug. It's a buffer overrun, right?
We wanted to speak about ChatGPT and
lightning round right now, guys. We're gonna finish it off with this one. So ChatGPT, I just read it in a Visual Studio magazine that the most downloaded extension in the VS Code marketplace is actually from Daniel Avila. And it's called CodeGPT. It has 51,115 downloads, and it promises to help coders use the official Open AI API inside Visual Studio Code IDE. Now, let's not forget that GitHub Copilot was launched back in 2021, went public in 2022. Not sure what's going on. But in this lightning round, I want everyone to give just a quick, and we'll start with you, Greg, on your thoughts about ChatGPT and the future of coding in general.
Yeah, so I'm going to going to confess some ignorance now. Can ChatGPT write C++ code? I know it can write Python.
Yeah,
somehow.
It can write anything. It can write in a language that you just invent, teach the bot about the language, and then ask it to write in your own new language. So it is fascinating.
Write some C++ to do. The reason I ask is I think we're coming back to this point that we raised earlier, this notion of Pythonic. I can imagine that the ChatGPT and more generally the generative AI will be, I think, potentially really problematic with C++. I think with Python code, for example, where you've got this notion of Pythonic, and there's all the code it's reading to learn kind of looks a certain way and does things in a kind of standard way that will kind of fit together. Whereas we've spoken multiple times about the kind of multi-paradigm pros and cons of C++, and I just think the potential for generative AI to write subtly bad C++ is just, we know humans are prone to it, and I think that AI is going to be too.
So I can say that exploring ChatGPT with C++, I can agree in a way at the current moment, but it will improve, and the same as we humans improve. And we learn how to, take the right approach, even though we see different examples. It will improve. You see it happening during the current time.
Yeah, of course. I mean, no question, it will improve. But I think that, and as it does so, we will. I mean, not really even started, right? There is very, and I'm sure that an insignificant amount of actual running code out there is generated by AI. That will change. That will surely change, and it brings with it some just brand new big questions around copyright and the kind of supply chain. We're seeing supply chain attacks become increasingly the kind of cutting edge of sort of black hat attacks, and this weird kind of non-deliberate almost supply chain attack potential and
new safety challenges.
I think it's happening. I'm not, it's coming, right? But it's just going to bring, with it, new challenges that we haven't really even begun to think about.
Yeah, for me, it seems like a game changer. I mean, it would not be the same way that we write project and code today. It's an actual game changer. We still cannot see the entire picture of what our project would look like. I mean, part of the projects would be written by machines. And then it bears much more responsibility on us as humans for auditing this code, making sure that we use the right snippets.
On a personal level, I'm very excited by it, right? I think it's going to bring some really big debugging challenges and kind of accountability challenges that I'm kind of, I've got dollar signs in my eyes. I'm rubbing my hands with glee. But I think particularly that there's a court case coming now, isn't there, with the copyright challenges from it. We could have a whole webinar about this. It's really interesting subject, I think.
Yes. Excellent. All right. So for our time is up, and I wanted to thank again our panelists for joining, and for you, the audience, for taking part in this riveting conversation. Hope to provide more of these in the future, and have a great rest of your day. Bye.
Much fun. Thank you very much, everybody.
Thank you. Bye-bye.
Bye.